Hey guys, today we're going to take a look at what we call distance time graphs. Now, what a distance time graph is relatively straightforward. It's just going to be a graph that compares the distance that an object is from something over time. So for a distance versus time graph, we're always going to compare the distance on the y-axis versus the time on the x-axis, and that's of course because time is always independent. It can't be affected by anything. Okay, so let's take a look at example 1 here. Liam is walking to SDHS from his house. He walks slowly. I'm actually going to pause, and what I'm going to do here is I'm going to just set up our graph. It doesn't actually say this, but we're going to set up our graph. And before I even get into the details of how he does this, we're just going to identify here the independent variable. That's going to be our time, like I just said. Okay, that's going to be our time. We're dealing in hours here. Okay, and our dependent variable is going to be distance. And like I said, this is always going to be the case for distance versus time. Okay, the units may change, but time will always be independent. Distance will always be dependent. So I'm going to label my axes here, just so that we can walk through this step by step. Okay, and there we go. So first of all, let's take a look at. We're just going to walk step by step to from where Liam is. So after no time has passed, okay, this is the distance from his house. Okay, so he starts at his house. So he's going to just be right at the origin. So I'm just going to put a little dot. I'm actually going to make this a little bigger, I think, if I can figure out how to. Let's make it, oh, that's way too big. Let's go. Yeah, that looks good enough. All right, so there we go. There we go. That might have been way too big. We'll see. Okay, so Liam is walking to SDHS from his house. So he's going to cover 10 kilometers. And it's going to take him 4 hours. So the distance covered, and let me just do this in green, he's going to get to the 10, okay? But it's going to take him 4 hours, okay? So after 4 hours, he's at 10, which means that he is going to be at this point right here, okay? So that's where he's going to be. So now once we've got those 2 points, we can, of course, draw a straight line. And there we go with a straight-ish line. Okay, oh, and there's not, I don't even know where that came from. All right. So after that, what happens? He then takes a break for 2 hours to fix his hair. So we're going to think about what this is going to look like. And this is where people often have troubles with this. You have to think about what this is saying. So this here is the distance. I don't know why. Oh, it's because my eraser. Whatever. This axis is the distance from his house. Okay, so he's going to stop at the 10 kilometer mark. So the bottom line is he's not moving anywhere, which people will often put it back down to 0. But he's just going to stay where he is the thing. So after 2 hours, okay, his distance from his house hasn't changed, so it's going to stay at that 10. So it's going to 2 hours is going to pass, and he's still going to be in that same spot. Okay, so there he is fixing his hair. Okay, upon fixing his hair, he realizes he forgot his textbook and walks 10 kilometers back to his house, but this time it'll only take him 2 hours. Okay, so he's going to go back down. I'll use the green again to show you. He's going to go back down to 0. But it's only going to take him 2 hours. So he started at 6, so it's going to take him to 8. So we're going to have a dot there. Okay? And once again, we will just draw ourselves a straight line. And once again, my line is straight-ish. Close enough. You'll notice that it took him less time. And so, I mean, we're going to talk more about this in the next unit. But you'll notice that this line I just drew is a lot steeper than the last line. And that's because he was walking a lot faster. Okay, so now he's at home, and he's going to play League of Legends for 3 hours. Okay, so 3 hours is going to pass, so it's going to take us to 11 hours, and his distance again hasn't changed. Okay, I didn't even try to do it straight that time. Close enough. Okay. So after 3 hours, no distance has passed. He's still at his house. So then he realizes he's super late for class, and in 1 hour now, he's going to run 10 kilometers. So he's going to run back up to that 10, but this time it's only going to take him to the, it's only going to take him to the 12th hour, okay, because he's going to run fast. And again, you'll notice that this time the line is going to be even steeper. And there we go. Okay. All right, so let's take a look at another one. This one, it's actually done for us, so we're going to talk about what has actually happened here. Okay. So the following graph represents the relationship between Charlotte's distance from home on a bike ride and time. So we're going to describe the 3 segments of Charlotte's ride. Okay. I actually see 4 segments, so we'll describe the 4 segments. There we go. All right. So the first thing that happens, if you look here, so Charlotte is at 0 distance. So she's starting at home. Okay. She starts at home and she moves at a constant pace here. She goes, and so she's getting further and further away. And so after 10 minutes, that part ends. So for 10 minutes, she walks at a constant speed, up until she reaches 10 kilometers. Okay, so the distance traveled here is going to be 3. Okay, the amount of time that's passed, well, we said it was 10 minutes. In the direction, well, she's moving away from home. So we'll say away. Okay, maybe I should be using, let's try a skinnier pencil now. It doesn't work so well here. Away, there we go. All right. So now we can figure out the speed by taking the kilometers that she's gone and dividing by the amount of time it took her. So to find kilometers per minute, we just say 3 over 10, which equals 0.3 kilometers per minute. And because we have the units up here, you don't have to include them. Okay, in fact, we should add them. This is in kilometers and this is in minutes. Okay, nice easy way when you've got a chart like that. If you put the units in the title, you don't have to write the units anywhere else. All right, so now let's look at segment B. Okay, so segment B here. So I'll switch over to, let's go red. Let's give it a little bit. There we go. All right. So segment B here. So Charlotte is 3 kilometers from home. And between 10 minutes and 30 minutes, so, well, actually it's less than that, 25. So we're going from 10 minutes here to 25 minutes. So 15 minutes have passed. Okay. And in that time, her distance from home remains constant. So what that means is that the distance she's traveled is 0. Oh, I don't learn from my mistakes. There we go. Well, no, let's do this. There we go. So 0 kilometers she's traveled. So in other words, she's sitting there in the same spot. She's not going anywhere. Okay, so 15 minutes pass and she hasn't done anything. So what direction is she headed? None. She's not going anywhere. And so what's her speed? Well, it would be 0 over 15, which of course just equals 0. So she has no speed. She's stationary. All right. So then we move on to segment C. Let's just use blue. Okay. So she starts in that same spot, and all the way until 50 minutes, she is going to travel from, she's going to be moving. Now you'll notice she's going a lot slower. You can tell she's going slower because this line's not as steep. Okay. So she goes from 3 kilometers away up to 4.5 kilometers away. So she goes from 3 to 4.5. That means she traveled a total of 1.5 kilometers. And it took her from 25 minutes to 50 minutes, which tells us that it took her 25 minutes. Okay. Her direction, well, she's getting further. Again, that number is increasing. She's getting further away. All right. And so how much, or what's her speed? Well, she traveled 1.5 kilometers over 25 minutes. So that's going to give us 0.06 kilometers per second. Or per minute, sorry. Okay. All right, so that was this segment here. And then we have our final segment, which we'll switch back to red. So this time she's now 4.5 kilometers away. Okay, she runs for 1 square, side to side. So she starts at 50 and she goes to 55, that would be, because each one's 5. Okay, so she's going to go for 5 minutes. Oh, for crying out loud. I just never learn. 5 minutes. And how far did she travel? Well, she went from 4.5 back to 3. So again, it's 1.5. But what you'll notice this time is this time she's running towards home. And that's what it's going to mean if she's going, like if it's going down. The distance between her, where she is, and her home is decreasing. So she's getting closer to her home. All right? And so her speed is going to be, oh, I almost did it again, 1.5 over 5. Okay? And that's going to convert to 0.3, which you'll notice we had 0.3 right here, and we have 0.3 here again. And if you look at those two segments, you look at this segment here, this guy right here, and this guy right here, okay? Even though this one's shorter because she did it less, she didn't go as long at that speed, you can see the steepness is the same. This one's going down because she's running in the other direction. This one's going up because she's running away from home. Okay, but the actual steepness would be the same. Okay. All right, that's it. So until next time, go Sabres.